So before we start with the graphs, we are going to learn another few things, that is called the uniform and non-uniform speed, and average speed and average velocity. So today in this video we'll learn only these two things, what is called average speed, average velocity, uniform and non-uniform speed. It's a very important one. So think about what is the definition of uniform speed. So it is called if an object covers equal distance in equal interval of times, however small the intervals be, it is said to move with a uniform speed. So meaning of this is this is the path here, and here is one object here. Here is one object. This object is moving in this direction. This object is moving in this way. So there is an equal interval and equal divisions there in the road. So each and every 1 hour, suppose each and every 1 hour, it is covering equal distance. Say it is 2 km. Again, next 1 hour, it is covering 2 km. Okay. So what you can say? Each and every equal distance in equal interval of time. So then this is called uniform, or that's constant. So example is, say the speed of light is how much? 3 into 10 to the power 8. Okay, 3 into 10 to the power 8 meter per second. Okay, sorry, the meaning of this, the light will cover 3 into 10 to the power 8 meters. It's a very huge distance in each and every 1 second, each 1 second. That means it's a constant. Okay, each second the light will cover 3 into 10 to the power 8 meter distance. So that is called uniform. Now what is non-uniform? We'll come to this point again. What is non-uniform? Again, this is the object. There are two cases. What is the definition? First I'll read. If an object does not cover equal distance in equal interval of times, its speed is called non-uniform. What is the meaning of this? Two things can happen. So first, this is 1 kilometer. Okay, this is also 1 kilometer. Every distance are 1 kilometer here marked. Now for the first kilometer it takes 2 hours. Okay, for second kilometer it takes 3 hours. For this kilometer it takes 1 hour. So what you can see, every distance is not covered by the equal time. Again, opposite thing also can happen. Suppose each time are same. This is 1 hour. So this is 1 hour. This is also 1 hour duration. But the car is covering, in the first 1 hour, the car is covering 2 kilometers. Second 1 hour, the car is covering 5 kilometers. And third hour, the car is covering 7 kilometers. So what you can see, the car is not covering equal distance in equal interval of time, or opposite also, it is not in equal time or equal duration in equal intervals. That is also, you can say oppositely you can also say. So that is why this is not uniform. Okay, that is non-uniform, or variable, you can say. It's the speed is varying. So that is non-uniform speed. Now next one will come, what is the average speed and average velocity. Very, very important thing. Average speed and average velocity. The same diagram I will explain. So first we'll learn about average velocity. Average velocity. V average, short form. Average velocity. Suppose this is a station, or this is a place A, and this is the place B. Okay, you are going straight in this way. In this way you are going straight, but your velocity is there, but your velocity is changing. How it is changing? Suppose you are coming straight line, there is no doubt, but when you come, your velocity was different. When you reached here, your velocity was different, because you are not covering equal distance in equal interval of time, but you are going straight line. There is straight line is there. Okay, so in this case, what you have to do, you have to, if you want to find out the average thing, what is the meaning of average? Suppose if I ask question how many students, what is the average marks of science in your class? Okay, then the answer will become, suppose say 70. Okay, 70. What is the meaning of this one? So everyone got 70? No, someone got 90, someone got 95, someone got 10 also, someone got 5 also. So what do you add all the things? We add all the things. We divide the number of the students, and then we'll get the average value. Then we'll get some average value. What is came here? 70. So here also, here we'll measure the velocity. Here we'll measure the velocity. Here we'll measure the velocity. So this way, if we do, then it's very much complicated. So what we did here, we'll find out the total distance, or here you can say it's not total distance, displacement. We'll find out the total displacement, that is called, say, S. Okay, total displacement, and we'll find out the total time, suppose say T, to cover the initial and final position. Okay, then we'll divide. So what we'll say, so V average is equal to total displacement by total time. That is the average velocity. So remember, LBM direction is there, that is why it is velocity. Okay, so total displacement by total time is known as the average velocity. Now what about the average speed? What is average speed? So here again you have to draw this type of line. So this type of, draw different type of line. Let's draw. So this is the line. Okay, now here is one point, again here is one point, and here is another point. So this is not a straight line path, this is A and B position, A and B, and object will travel in this distance, like this. It will travel in this distance. So here you can say the path traveled is the distance, because this is not the shortest distance. This is the some any kind of path is this, the A to B you have traveled, the object has traveled. Now in this case, here when the object, this is the object, when the object started, the velocity was much more higher. Then he stopped here, he was sitting here. And think about the story of the hare and tortoise. What happened? The tortoise was coming constantly, okay, but what the hare did, here first he started with a very high velocity, then he become tired, then he was sitting here, so waiting, okay, waiting and went to sleep. And the tortoise crossed the line, crossed him, and he became fast. Okay, so if I want to find out what is the average velocity, average speed of the hare, then what we will find out. See, first the velocity was much more higher, then he was sitting in a particular place. That time the speed was 0, and again he gained the speed. Like this way, different position, it is having different speed. Again same thing. First we will find out the total distance. What is the distance? So total distance, say S is the total distance, and total time will become T. Okay, so average speed equal to total distance by total time. Okay, so today what we learn about uniform and non-uniform speed. Or the example I gave for uniform, there is the speed of light. What is the example of non-uniform speed? Non-uniform speed means, suppose you are going through a very crowded market, you are going, so can you go in a constant speed? No, because sometimes you go faster, sometimes you go slower, somebody will come in front of you, you stopped also. So that is why there is a non-uniform. Okay, it's not fixed. Okay, and we learn about average velocity and average speed. Okay, so today next class will continue from the graphs. Different type of graphs we learn: position time graph, velocity time graph. We learn how to find out the acceleration, how to find out the velocity. Okay, thank you very much.